Hello, starting a new unit. It's going to be about some rational functions, and today we're going to be graphing simple rational functions. All right, so basically a rational function is some type of function or a number that you can write as a fraction. So again, if we had any type of polynomial, could be a series of numbers, x squared minus 2x plus 1, could just be a number, whatever. But again, of course, we can't have a denominator of 0. And then we also have an inverse function, which we kind of describe as if f of x equals a over x. Again, a is can be 1. So if we pretend that a is 1, this is kind of our parent function. This is what we're going to kind of imagine in our brains when we hear about the function that looks something like this. Okay, important parts right here is a line, and this line never gets crossed. So this is a vertical asymptote, which means it's never going to get crossed, and that's at x equals 0. So that's the line x equals 0. And there's also a horizontal asymptote. So I'm just going to say horizontal. Oh, excuse me, I said those wrong. So my vertical asymptote is the orange one. Here, let me fix that. Apologize. So again, the vertical asymptote is the orange one, and that's the line x equals 0. It's never going to cross. Our blue function is never going to cross. And then the yellow one is our horizontal asymptote, which is the line y equals 0. It's never going to cross. So say that we wanted to compare. So if this is our parent function, and again, this is 1 over x, if we wanted to compare that to, say, a function that is 6 over x. So again, just going to kind of draw up our initial graph. Looks something like this. Again, if this was like a quiz, I would want you to specifically plot these points. So we're going to graph y equals 6 over x. So if I were to find a couple points to the left and right of my asymptotes, so again, I still have this vertical asymptote and I still have this horizontal asymptote. The vertical asymptote is x equals 0. And my horizontal asymptote is y equals 0. And then my new graph, y equals 6 over x, is going to have points at x is 2, y is 3, x is 3, y is 2. So it's going to be a little bit steeper because it's 6 over x. And it's going to be kind of the same thing down there. We can use Desmos to check it out. So our parent function is, see here, give me a fraction. 1 divided by x. Okay, we've got this. Let's kind of make it bigger so we can see. And then when we put our new function, 6 over x, you can see the black graph, how it has kind of shifted out a little bit. So of course, this is going to lead us to some kind of translation rules. And so kind of the general translation rules kind of go like this. If we take the function, this is our base form, a over x minus h plus k, you follow these steps. So step 1 is draw the asymptotes. And then in this case, x equals h for your asymptotes and y equals k for your other asymptotes. And then draw the two branches of the hyperbola so that they plot the points to the left and right. So then step 2 is plot your points to the left and right of the asymptotes. And then you can draw your lines to finish it off. So let's do an example. Y equals -4 over x plus 2 minus 1. State the domain and range. All right. So first step is I got to identify my asymptotes. So I see that I have x plus 2 is one of them. That's right here. And then I have plus k out here and a minus 1 right here. So that's telling me that my my vertical asymptote, so this yellow one, my vertical asymptote is x plus 2 equals 0, so x equals -2. That's my vertical asymptote. My horizontal asymptote is just going to be y equals -1. So again, if we're just thinking, okay, here's my graph. Let's say here, -1, -2, -3, -4, 1, 2, 3, 4, 1, 2, 3, 4, -1, -2, -3, -4. Perfect. My asymptotes, and this is how you draw in asymptotes, you use a dotted line or a dashed line. So x equals -2 is my vertical asymptote. And you got to label it x equals -2. And then my other asymptote is at y equals -1. Okay, so that's good with that. And then I got to start plotting points. So again, if I were to plug in, all right, my most immediate point is -3. So let's plug into our equation a -3 for x and see what our answer is. So when x is -3, y is 3. And then when I do x is -4, I get an answer of y is 1. So I know that because of where my asymptotes are, my graph is going to look something like that. And then if I move to the right, okay, let's find when x is -1. So when I plug in -1, I'm actually going to get -5. So I need to go one more. And then, so x is -1, y is -5. When I plug in a 0 into this equation right here, when I plug in a 0, I get y equals -3. So again, I would need to see at least 2 points for each of the curves. I would need to see the label of your axes. I would need to see we would have to see where the asymptotes are. And then to finish this question off, state the domain and range. So our domain is going to be all real numbers except -2. X cannot be -2. And then the range is all real numbers except -1, because that's where our asymptotes are. So we know that we can't have those answers there. All right, last example. We're going to graph a function in the form of y equals ax plus b over cx plus d. So just kind of keep that in the back of your mind. Here's the actual function. Y equals 2x plus 1. X is x minus 3. State the domain and the range. Ugh. All right, so the first thing I see is that I'm going to have, because of this x minus 3, I know that I'm going to have a vertical asymptote. So what would make this equal to 0? So that's my vertical asymptote, which is 3. So again, if I'm going to be graphing this, let's draw our graph right here. I know that at 3, I'm going to have an asymptote. The horizontal asymptote is the line A divided by C. So again, if I look at A and I look at C, okay, that's 2 and that's 1. So my horizontal asymptote is A divided by C, which in this case is 2 divided by 1, which is 2. So I'm going to draw at x is 2, or excuse me, when y is 2, I'm going to draw in my other asymptote. So now I've got points that I can pick. If I pick when x is 2, I get y equal to -5. So when x is 2, y is -5. And when x is, I like to pick 0 just because 0 can sometimes make the math much easier. Y is -1/3. So we know that our graph is going to be, I kind of missed it right there. Okay. And then we have to do it on the other side. So if I pick a couple more, let's see here, 4, 5, 6. If I pick when x is 4, I'm going to get y is an answer of 9. So that would be all the way up here. And then when x is 6, y is 13/3, which is again a little bit more than 4. So if we said this is 3 and 4, be about right here. All right. So that's kind of, again, the one tricky part about this one is while your vertical asymptote stays the same, your horizontal asymptote, notice you had a slightly different problem. You had to do A divided by C if it's in this form. We got to finish off with the domain and range. The domain is going to be all reals. So again, this fancy R, all reals except 3 because we have an asymptote. And our range is going to be all reals except 2, same reason. We have an asymptote.